Bismillahirrahmanirrahim. In this video, which is about voltage induced in a rotating loop, I'll be solving end chapter problem 8.1, and this is on the request of a student. So straight away on the question, the following information is given about the simple rotating loop shown in figure. So this is the rotating loop, and you can see here also this is the loop. Just one loop is considered, which is rotating. A voltage source is supplying, or a battery is supplying the current. There is a resistance, there is a switch, and I hope you know this is the slip ring, and brushes are attached with it. What all is given is B 0.8 Tesla, B is the flux density, L 0.5 M is the length of the coil, this length, R 0.125 meter is the radius, this is the radius, VB, as I mentioned, voltage supplied, or the battery voltage is 24 volt, this resistance is 0.4 ohm, and it is rotating at a speed of 25 to 50 radians per second. So we have to find out these parameters. So we'll do one by one, and just for you to remember, this is flux density, length, radius, battery voltage, resistance, and the rotational speed. So let's take the first part, or part A. Is the machine operating as a motor or a generator? Let's see. First of all, we'll find the induced voltage inside the machine, and this is the formula that has been derived in equation 8.5, and from that we can write it as 8.5a. So 2 into radius into length into flux density into rotational speed will give the induced voltage, and these are the values that are given. So we'll plug in the value, and solving we find the induced voltage to be 25 volt. Now the machine is producing 25 volt, the battery has 24 volt, that means this is feeding, or this will feed the battery. Generated voltage is 25 volt, whereas the external battery voltage is 24 volt, as the machine is operating as a generator and it is charging the battery. Then part 2 of the question, what is the current I flowing into or out of the machine, and what is the power flowing into or out of the machine? So the current is simple. We have the battery, we have the resistance, and we have another voltage here, 25 volt. So we'll straight away by a current formula, or the Ohm's law, I is E induced minus VB divided by R. Because the generator action, the current will be flowing out. So the current will be flowing out because this voltage is 25. And so from this formula, E induced 25, VB 24, R 0.4. So current out of the machine is 2.5 ampere. And the power flowing is simple. P is equals to V into I. So the power out of the machine is E induced into current, and which will give 62.5 watt. So this is part B. Part C, if the speed of the rotor is changed to 275, so earlier it was 250, now it has been made 275, what would happen to the current flow into or out of the machine? Again, we just replace this one, 250 by 275, so the voltage is 275, so it is more voltage generated, and therefore the current will be coming out. The same formula, putting in the value, current is now 8.75 ampere out of the machine. And the last question is, if the speed of the rotor is changed to 225, what would happen to the current flowing? So we just find E induced. E induced for 225 will be 22.5 volt. And since the generated voltage is less than the external battery voltage, the machine will now act as a motor because the battery is 24, inside is 22.5, so battery will be feeding. That means it is operating as motor. And the current formula, since VB is greater, therefore we'll write it earlier, VB minus E induced divided by R, so 24 minus 22.5 divided by 0.4. So current now is 3.75 ampere, and obviously it is flowing into the machine. I hope this gives you an understanding how you can solve this type of question, a very simple question. Thank you.